Today we're talking about very, very early development from the prenatal stage through infancy. So we'll start with the germinal stage from conception until about 2 weeks into the prenatal period. Then the embryonic stage, where you could see the development of the central nervous system is really happening from about 3 to 8 weeks. And then into the fetal period, which we consider about 9 weeks until birth. So during the germinal period is when the fertilized egg is undergoing a really rapid period of cell division. It's when sex determination is determined by genotype, although we'll come back to sex determination in a minute. And it's also a period when the developing zygote is the least vulnerable to environmental influences like teratogens, which are prenatal toxins that may pass through the placenta. We'll talk about that in this video as well. During the embryonic stage, cells are starting to specialize into organ systems. They're starting to differentiate. During the embryonic stage, embryonic stem cells actually can morph into or turn into any organ. And then the fetal period from about 8 weeks to development is when we start to see spontaneous movement because of the development of the somatic nervous system. So to talk for a minute about the determination of physical sex characteristics, probably you've learned about this in biology, that the mother gives an X chromosome, and then either the X or the Y from the father is what determines the sex of the child that is assigned at birth. So an XX would result in female, and XY resulting in male. However, going beyond just this XX and XY, there's actually a lot of complexity to sex determination. You maybe at some point have been introduced to the notion that gender is seen on a spectrum. So in other words, focusing not just on the binary parts of the spectrum, but on the non-binary parts of the spectrum as well. A person who's non-binary identifies as neither completely female nor male. A person might identify with both genders or neither gender, or they might be a gender that's fluid, meaning gender can fluctuate between female and male. So you might already be familiar with the gender spectrum, but you may not be familiar with the notion that physical sex characteristics as well can happen on a spectrum because of a variety of chromosomal or genetic anomalies or mutations. So just real quickly to review, factors that determine sex starting at conception are chromosomes, like we just discussed, genetics. During the prenatal period, the influence of hormones can also play a role in the development of sex characteristics. If there's elevated levels of male hormones or resistance to male hormones during the prenatal period, that can also, again, affect sex characteristics. At birth, we see both internal and external sex organs, but again, there's an array of possibilities depending upon genes and chromosomal combinations. And finally, at puberty, there's the development of what we call secondary sex characteristics, such as breasts and facial hair. Think about all of the changes that the human body undergoes during puberty. We refer to these as secondary sex characteristics. So if we start up top, or we're looking at this spectrum of biological sex, we see, from a typical biological female, the XX, like you learned about in biology class, to a typical biological male, an XY, you have all of these possibilities in the middle as well. Again, that might result from chromosomal anomalies or genetic mutations, but let's just take Klinefelter syndrome as one example, with there being an extra X chromosome. An individual with Klinefelter syndrome at birth will exhibit both male internal and external structures, but then during puberty, when we have the development of secondary sex characteristics, because of the presence of low testosterone, there will be small testes, infertility, reduced facial hair, weak muscles, breasts may develop. This can be treated with hormone therapy to promote male characteristics if the person chooses. But Klinefelter syndrome is just One example of what we see in this variety of what we call intersex conditions on this spectrum of biological sex. So getting away from this notion as even sex assigned at birth being only, binary, biological female or biological male, I think it's important to point out this spectrum as well. And we'll talk a little bit more about sex assigned at birth and gender and sexuality as we get to the end of this unit. Also during the germinal stage is when we would have, for example, parents contributing, in some cases, mutated recessive genes. So two parents who phenotypically, meaning in terms of physical characteristics, seem normal, maybe both be carrying genotypes that have these mutated recessive genes that can result in different disorders that the child might experience. An example of those is PKU, or phenylketonuria, which is an inability to digest proteins. And if not corrected with diet, if those excess proteins reach the brain, it can result in neurological impairment.
I was born myself with a rare disorder, PKU.
I have PKU. PKU is short for phenylketonuria.
I just put it in the easiest terms for people, and I tell them I'm allergic to protein.
PKU is a deficiency where patients can't break down, or what we call metabolized protein.
Too much of it, it's toxic.
Excess phenylalanine goes into the brain and it causes damage. I got a call that Connor's newborn screen had come back positive for something called PKU. I remember that night, I'm holding this baby in my arms. I'm breastfeeding him. I'm giving him nourishment, and I feel like I'm feeding him poison.
I can't have meat, but also dairy, nuts, fish, sometimes regular pasta, carbs, is bread's too high in protein. And that's when they're really like, oh, wow, when they realize how severe it is.
And if they don't restrict the Phe in their diet, then they have these horrible neurocognitive problems.
My focus was really off. It was hard to focus in school.
Forgetfulness, I'll get frustrated really easy with simple tasks.
Extreme fatigue, headaches. The high Phe can have harmful effects on the brain that make it hard to do even just everyday tasks.
So again, PKU is an example of a disorder that can develop as a result of the genotypes of both parents. So now moving into this embryonic period, you'll see that during this embryonic period is really when the critical periods of human development occur for all of these major systems and parts of the body. The black areas that you're seeing here are the most critical spans of time for the development of each of these parts or systems. So from about 3 weeks until 5 weeks is a really critical period for the development of the brain and the spinal cord or the central nervous system. The heart, also critical period, is about within this time. And what's significant here is that if a developing embryo is exposed to any type of toxins like drugs or alcohol or tobacco during these critical periods, it can lead to really major abnormalities. Remember that during the germinal stage, the developing zygote is really not usually very susceptible to these types of toxins, which we're going to call teratogens. The placenta is the organ that develops between the embryo, fetus, and the mother, where the mother is able, through what they are eating and drinking, to provide nourishment to the embryo or fetus. But the placenta is only good at screening out some toxins. So there are other toxins like teratogens that we're talking about right now that can pass through the placenta and can have really damaging effects on the development of the organism. You can see that, again, it's during these critical periods in the embryonic period when the most abnormalities or the most damage can occur. And then as we get into the fetal period from about 9 weeks on, we can still see negative effects from exposure to teratogens. One example of a syndrome that can occur from the result of this type of exposure to teratogens is fetal alcohol syndrome. And these are some of the physical characteristics that may be seen in a child with fetal alcohol syndrome, in addition to cognitive impairments as well. For this reason, the FDA classifies all drugs using these categories A, B, C, D, and X. They rank them according to the degree of research or controlled studies that have been done in both humans and animals, and whether or not those studies have shown any potential risk to a developing fetus. So a drug like a Tylenol or an ibuprofen, I believe, depending upon the trimester of pregnancy, ranges anywhere from a B to a D. Whereas maybe you've heard of Accutane, which is a drug that's used to treat acne. That is classified as X. If a person's going to go on Accutane, they have to take a pregnancy test to guarantee that they're not pregnant at the time that they begin it, and then they have to be on birth control, because controlled experiments done in both humans and animals with that particular drug demonstrate that there are fetal abnormalities that occur as a result of using the drug, and the risk in a pregnant woman outweighs any potential benefit. Unlike maybe in a class D drug, where you could argue or you could say that though there might be some risk, the benefits outweigh risks in certain situations. So in other words, if a drug really guarantees the health and wellness of the mother, that might be an example of when, even though there's some risk to the fetus, it would still be something that could be taken because the benefits outweigh the risk. During the prenatal period, brain development is really, really incredible. The brain is growing neurons at the rate of 250,000 a minute, so that by the time a child is born, they have 100 billion neurons. And all neurons are coming from cells at the top of what's called the hollow neural tube. These cells eventually become the brain, migrate out of this neural tube, and extends axons and dendrites to connect to other neurons, and this is where we have the development of the brain and the central nervous system. During the neonatal period, so from birth to when a child is born until about 1 month, babies are born nearsighted, so they can't see far away, they can only see close up. But by about 7 weeks, they're able to make eye contact and scan their caregiver's face. By about 1 to 2 months, they're able to differentiate between colors. And by about 3 months, they're starting to develop the ability to perceive depth, although we learned that develops further as the child starts navigating their environment and crawling, if you remember from the visual cliff experiments. But during this period of time, it's really interesting when we get into studying morality. There are researchers who study things like, are we born with a sense of morality? And how would you even measure it in a newborn? Well, really young babies, not only in the newborn stage, but in the infancy stage as well, they will stare longer at things that they like. So anyway, you'll see when we get to when we start looking at some of these examples, it's really interesting the characteristics that newborns possess. I hope that you'll take a few minutes when you're finished this video and watch the video that I put in your notebook about newborn reflexes. You're going to see a really, really adorable newborn demonstrating each of these newborn reflexes that are exclusive to newborns. These reflexes will disappear by the time a baby is, anywhere from several months until a year old. An example of a newborn reflex is the rooting reflex, where if you stroke a baby's cheek close to their mouth, they'll turn their head in the direction of the cheek that's being stroked. And this enables them to latch on to their mother in order to feed as soon as they're born. But again, it disappears by about 4 months of age. And that brings us to this last period that we're talking about today, which is infancy, from about 1 month of development to when a child is really developing language at about 18 months. The brain is shifting now from creating new neurons to making new connections. Neural mass is increasing tremendously, and babies are also undergoing what's called synaptic pruning, where important connections are being consolidated and unused ones are being lost. You, as a teenager, are also going through a period of synaptic pruning right now. Tons of changes are happening in your brain. Babies at this time are learning through classical conditioning. They're learning by association. And they're very, very, as we learn when we talk about cognitive development, they're taking in information at all of their senses, and they're responding to sensory information coming in at all of the senses, which is why you see, colorful, noise making, very like textured toys that are made for babies.